So now that we've defined the block and even modified it in our workspace here, we can now go and look at the code generation. So in the tutorial, it points us to the place where the code generation is defined. So first we look at the code generator, and then we will see how it is attached to the rest of the application. So the code generator that we're going to use here, that's in source generator TS. So in our workspace, here we go. We had the main and the blocks. Now there's the generator TS. We import the Blockly API, and then we're going to define a new code generator. So here we're going to use a Blockly generator for the language, and we call this language pseudocode. So that's just a string. There are default code generators that come with Blockly, for example, for Java, for Python, JavaScript, Python, and other languages. We're going to define one from scratch. We're going to configure it. That has some indentation with 2 spaces. And this thing will be called the pseudo generator, but now this generator would not do anything yet. What we have to do is we have to define functions for our new blocks. So here we have this greeting block. And then we're going to say here there's a function, and this function has a specific signature. It gets a Blockly block, and it returns a string. So we need to return a string for our greeting block, and we could do this for the other blocks as well. Well, our language only has one block, so that's why we only have one function here. And this function is then called whenever we want to generate code for this block. So there'll be a place where Blockly will try to generate code for the workspace, and then it will see, oh, I have a greetings block. That's the type that we defined here. We defined here the type greeting. We'll say, oh, I have this greeting block. So now let's try to generate code for that block. Now, in this code generator, we're first retrieving the number of times we want to execute something, and then the subject we want to greet, right? So the example running had this number that we can enter. So let's say 5 times hello, right? And the code generator didn't work, right? So now maybe based on the connection that we're looking at here, we're seeing why, oh, that was not intended. Maybe we're seeing why this doesn't work, because actually those values here, they say get field by name from this block, and this field times, let's see whether it exists. This field times, does it exist in our block definition? No, we renamed it to mal. The field subject exists, right? So actually, if we want to migrate our code generator to this more German-like code generation, then we should say this field value is actually mal. So how many times do we have to say something? Copilot is too smart. It's already suggesting this fix. So, but let's get there later. So we're extracting the number of times we want to generate something. That's this mal. We store this into this constant times value. And then we do some checks. So for example, we check if this number is finite, and if not, or if the value is less than 1, then we would return an empty string, right? Can this be? Can we have an infinite number or a number that is negative or 0? We can't really do that, right? Because it's, yeah, we could have 0. Any number that's not finite, we probably cannot enter it, because in our block definition, we said we're restricting it to these minimum, maximum, right? So the only thing that's probably going to go wrong here with these restrictions, if we remove them, many things can go wrong, right? But with these restrictions, we could probably get down to 0 times doing something. So I change this to mal. Now, hopefully our code generator is back on track. Our code generator closed. So let's see, where was the output here? Let's open it back up. So sag 5 mal Hallo Welt, then it's going to do that. Now let's see if this 0 thing worked. Yeah, if we put a 0, it's not generating anything, and hopefully it's not showing an error, but very likely it's not. Where was this? More tools, developer tools. Yeah, no errors here, and we can add some other blocks above and below, if we do this 5 times, and this 1 time. So we see there's also some special handling for the number 1 that our code generator does, but let's go back to our code generator. It first extracts the times value, right? How many times should we say it? And then it extracts the subject. Very simple. Again, get field value. Now that's a string, because here we simply defined it as a field input, and everything could be read as a string, I guess. Then we're going to say the code that we will generate is display, and then hello, and then the subject. Right now, if we want to change this to the German variant, we'll say hello. And this should change our code generation. So, hello, right? Yeah, now the label that we changed in the block definition and the code that we generate is now in sync, right? It doesn't have to be like that. It could be that the label is very, very different from the code. Here, it somehow happens that it's similar, so we should probably keep it in sync. Okay. And we're going to keep these like pseudocode, repeat, times, and display things, because usually you wouldn't really translate this, right? We don't need to translate it to German pseudocode. Right, usually you don't translate to a German Python version or something if you generate code. So that's fine. Let's assume that there's a fixed language for pseudocode that we're just going to use and generate this too. But yeah, how does the generation actually work? Here we're going to say we're going to assemble the code as display, hello, and then the subject value. So we're basically mixing the values that we have in our blocks with fixed code that we know we should generate for this kind of block. And then we're going to check, is the times value greater than 1? So if it's 0, we would have already returned an empty string. If it's exactly 1, then we would simply return this code here. And if it is greater than 1, we wrap it into this repeat some number of times, and then this code, right? So here, this \n, that's a new line. Then we're going to put the code in a new line with, well, 2 spaces, right? And then we're going to return the code. So this one, for every block, it will basically generate this piece of code. Yeah, now if it's only 1, then it's just going to say this display thing. If it's 5, it's going to say how many times, right? And then also for 100, it's going to say, okay, so that's our code generator that we now implemented. But now there's one tricky bit. So we have these chained blocks here, right? We have the blocks that we can click onto each other. And the default code generator basically has no idea that it needs to generate code for the remaining blocks as well. So we need to tell this default code generator, and that's documented in the tutorial right here. We have to basically we basically have to redeclare this scrub function to also generate code for the next block. Here, we're basically saying whenever this scrub that's a built-in function, we're basically saying if there's a next block, then we're going to take the current code and attach the code of the next block. And it can do that kind of recursively. So for each next block, it will then also append the code of the next block. And now we finally need to wire this code generator and combine it with our editor, right? So we haven't really done this yet, and it's not done automatically, but it's not a lot of code that we have to write. So this is our code generator. This is this scrub method, which makes sure that we're generating code also for the next blocks. And then back in our main, we are also importing our code generator. And then we're getting those 2 diff fields, the code output and the error output, because we will print stuff to it, right? We will assign the content of it. So this code output here, if we have this field, we're going to add the code, and this code actually comes from the generator that we defined. And this generator is our pseudo generator, and it has a method workspace to code. So this is a predefined one, because we basically in our generator here, we used Blockly's generator, and this will provide a method to code. This will then call at some point our for block code generation, right? So this is the one that generates code for the workspace, and it assigns it to this text content of the code output field, or it basically puts the error message. And then the last thing is that we need to tell Blockly, or our application here, when to actually execute this code. So we take the workspace and we say add change listeners. So whenever something in the workspace changes, if I change a value, if I change a block, then it's going to call this generate code. That's quite a lot, and maybe we shouldn't generate code that much, but it's very cheap to generate this code, right? So this add change listener, that's also a built-in function of the workspace, and we're just going to say, well, on every change, generate code, and that's what we see here. Whenever we change something here, say 9 times, then it automatically updates the code, right? This happens directly. Adding or removing, it automatically generates the code. Okay, so now we wired our code generator into this, and we also modified the code generator and the label on the blocks.